Cost value word problems are a lot like the number word problems, where you're going to have two things being compared to each other, but they're going to be compared two different ways. So if you look at the first one, it says a total of 720 people attended the school basketball game. Adult tickets cost $2.50 each, and student tickets cost $1.50 each. If $1,220 worth of tickets were sold, how many students and how many adults attended? So here we have how many students, and how many adults. So we want to figure out the number of students and the number of adults. And then we also have their ticket costs being compared to each other. So $2.50, $1.50 for a total of $12.20. So we're going to use the one piece to create our let statement, and then we're going to use the values to create our equation. So if I know 720 people came to the game, I know A of them. I'm going to let A equal the number of adults. And to get the number of students, if 720 of them came, you would just take 720 minus A for the number of students. So now we've defined our variables. So we know A represents the number of adults, and 720 minus A represents the number of students that went. So now we're going to take a look at the value. So if I know it's $2.50 for each adult ticket, and $1.50 for each student ticket, and I know $1,220 worth of tickets were sold, I can take the cost of an adult ticket times however many adults plus the cost of a student ticket times however many students. Yep, need some more room. Times however many students, so 720 minus A. So the value and cost of an adult ticket plus the value and cost of a student ticket times however many students and however many adults came is going to equal the total amount that I was given. So these are just like those number problems when we had the sum of two numbers is 15, 6 less than 3 times one of the numbers is 5 less than 12 times the other, or whatever it is. We're comparing these things two different ways. One, the number of tickets, or the number of people, and then two, their value. So once you solve this equation, you will get 140 adults and 580 students. So the next one is another one, a coin purse, I call it. You have $3.20 worth of quarters and dimes. There's 20 total coins. So again, you're comparing quarters and dimes two different ways. You're comparing the amount that there is, how many there are, and their worth. So our let statement is going to be let Q equal quarters. The number of quarters. I should be a little more specific. And then since there's 20 total coins, 20 minus Q is the number of dimes. Then it says their value. So if we know we have a total of $3.20, I have to think to myself, all right, well, how much is a quarter worth? How much is a dime? So if I take a quarter's worth, 25 cents, times however many quarters I have, plus a dime's worth, which is 10 cents, times however many dimes I have, that's going to give me the value of the quarters, the value of the dimes. Add them together, you're going to get the total value that's in your coin purse. So once you solve all this, you're going to get that you have 8 quarters and, spoiler alert, 12 dimes. So treat these just like those number problems when you have the sum of two numbers is 15 and then it talks about them in a different manner. You have the number of quarters and dimes, you have the number of students and the number of adults that attended the game, and then you also have the value